Welcome back to Chemistry 24/7 series. In this series, we are exploring the solution of previous year questions. This is the question from CSIR 2014. According to this compound react with series of 5 reaction conditions. Finally, which produce some compound, we should find out the correct product for this question. So let's break down the question and solve it together. So first you see the first reaction condition, reaction with propenyl chloride in the presence of triethylamine. So our compound having hydroxy group which readily react with propenyl chloride in the presence of triethylamine to yield the corresponding ester product. So the next step is the reaction of LDA. So LDA we already discussed in our channel. So this one is one of the strong non-nucleophilic sterically hindered base which readily takes the proton from acidic position. So according to this, when you use LDA which readily takes the proton from this side, which provide corresponding inlet ion. And when you use LDA, this type of compounds, you may get a mixture of E enolate as well as Z enolate. But in principle, when you use LDA in the presence of THF solvent, most probably you will get the E enolate as a major product because of steric reasons. However, in this particular case, when you use this reaction condition, you will get the Z enolate as a major product. At the same time, minor amount of E enolate also possible under this condition. At the same time, when you use HMBA, small amount of HMBA, that may possible to switch the enolate selection. That means that when you use HMBA, you may get the E enolate as a major product. Okay, how we can explain the formation of Z enolate as a major product? So we can explain through the transition state structure. So this one is here just like chair form of transition state. So here you see this one is a LDA part, and this part is corresponds to this compound. So this R part means that this heterocyclic whole part, and this methyl is here. So this CH2 is here. So now you look, this methyl can possible to present in the top phase as well as the bottom phase. When you put the bottom, so you may experience allelic 1,2 strain. At the same time, when you put methyl group in the top, so you may experience with syn diaxial interaction. But when it compared to allelic 1,2 strain and syn diaxial interaction, allelic 1,2 strain is manageable. So therefore, Z enolate is formed as a major product in this particular reaction. Next condition is the reaction between the trimethyl silyl chloride and enolate. This enolate readily attacks the silicon atom, which kick off the chlorine ion, which leads to generate corresponding silyl ketene acetal intermediate. So the next step is heating. So when you heat the silyl ketene acetal, which readily undergo 3,3 sigmatropic rearrangement. So for our better understanding, we can redraw the structure in this form. Now you see this group present in the top phase, just we put in the top phase, as well as this group also, silyl ketene acetal part also present in the top phase. So now you see when you use heating that undergo 3,3 sigmatropic rearrangement. So now you see how this happened. So this electron attacks this carbon, then followed by this electron shifted here, then followed by breaking of this CO bond, so which leads to provide this corresponding intermediate product. So particularly here you should note the stereochemistry of this reaction. So since this reaction takes place in the top phase, since this reacting group present in the top phase, or another way we can say this one undergo by supra-supra interaction. So what is means supra-supra interaction? The supra-supra interaction means that so both bond making as well as bond breaking event takes place in the same phase. So here you see the bond forming, the third carbon to third carbon takes place in the same phase of that CO bond breaking even. So therefore, this particular step is undergoes by supra interaction. So this this particular reaction is called 3,3 sigmatropic rearrangement. In specifically, this particular reaction is called Ireland-Claisen Rearrangement, which produce this corresponding product. Then followed by the next reaction condition is the treatment of acid. When you use the acid, the TMS group readily deproducted, which produce corresponding carboxylic acid as a product. So the next step is the reaction between the diazomethane with this carboxylic acid. So here you see the diazomethane, the negative charge readily abstract the proton from carboxylic acid, which produce corresponding carboxylate ion. After the formation of carboxylate ion, which readily attacks this carbon, and followed by kick off the nitrogen gas, which produce corresponding ester product. Here we should note the stereochemistry of this methyl group. Since this methyl group present in the wavy bond, that means that this particular silyl ketene acetal part present in the both E form as well as Z enolate form. I already pointed out in our previous slide, the formation of this enolate will be a mixture of enolate. It means that both E as well as Z enolate, however, Z enolate present in the major form. Therefore, here we represented in the wavy bond for methyl as well as all other products also.